All right, thank you.
Isn't the 1 minus sine squared below the 30.63 also supposed to be?
Remember that we were squaring that term, and so that's cosine squared.
Oh,
So how do you solve it? Or question for Tika or a solution?
I was just answering, rationalize the first part,
Rationalize the denominator.
yeah.
If we do that, we multiply top and bottom by that radical, so we end up with negative 50 is equal to 100. Let's see if I can draw an equal sign properly here. Equals 100 times the sine times the square root of 1 minus s squared, sine squared, over 1 minus sine squared, minus 30.63 over 1 minus sine squared.
and then combine like terms. I mean, since that they have the same common denominator, just combine two.
All right, so I got negative 50 is equal to 100 times s times the square root of 1 minus s squared minus 30.63 all over 1 minus s squared. Now then,
Multiply the denominator as on both sides to cancel out the denominator.
okay, so let's get rid of the fraction by multiplying both sides by the least common denominator. So that's negative 50 times 1 minus s squared equals 100 s square root of 1 minus s squared minus 30.63.
Are we wrong?
No, I would have done slightly different steps, but we haven't gotten to the crux of how we actually solve for this.
Now we have to show. Go ahead. The square, the negative 30.63 is not under the square root, right? So we
Correct.
would just add it to the 50.
Oh, take that over there? All right, so I have negative 50 times 1 minus s squared plus 30.63 equals 100 s square root of 1 minus
No,
s
no, no.
squared.
Like I mean like,
Add it just to the 50?
yeah.
No, you can't do that.
Oh, what?
Because that 50 is attached to this.
Okay, so then what do we go back and then attach it and then add it? No, never mind, I see what you mean.
Okay, we could just, in essence, distribute this and add it over. We have to do it in some way anyway. So that's negative 50 plus 50s squared plus 30.63 equals 100 s square root of 1 minus s squared. So now I've got these things unattached, available, and I got negative 19.37 plus 50 s squared equals 100 s square root of 1 minus s squared. We are cruising now. We still have this problem of how do we solve when we get the unknown under a radical?
Can we substitute our variables? I was just asking because, like,
Put in something for 1 minus s squared?
like the s could be, like, can we turn it like a quadratic function, like, or something? Like, if we substitute like the variables inside.
Quadratic function is gonna come into it, but we're not there yet.
Okay.
We have to deal with it.
Oh,
Well, it depends on how you want to approach that, but the way that I would do it, not ready for the quadratic yet. All right, Pratika, did you have your hand up?
Yes, I'm trying to. How did we get the s in the numerator?
The s in the numerator,
Like,
where? At which point?
from
Here?
the beginning, yeah.
Where we get that s?
Yeah.
If we go back, not that one, square. That one,
abbreviation for sine.
it was 40 sine theta. That's where that s comes from here.
Okay. Okay.
Yes?
So, can we isolate the square square root term by dividing by 100 on both, 100s on both sides, and then square it.
Yes, that's how it's solved. When you've got the unknown under a radical, you need to isolate the radical, assuming you have only one. You need to isolate the radical and solve it from there. Now we could just, because this is a single term with the radical, then again, from the language, factors, you multiply or divide, terms, you add or subtract. So this is a term. I could just square it at this point, or I could divide by 100 or 100s, however you want to do it. It's going to be slightly more convenient just to keep the s over here, but you don't have to. My first thought was get the radical all by itself, period. But I think we'll save a step if we just divide by 100. So this becomes negative 0.1937 plus 0.5s squared equals s square root of 1 minus s squared. Just divide it. When you divide by 100, you divide each thing by 100. I divided that by 100. You divide each term. Divide that term.
Why did we keep the s? Like, why did we not divide by 100s?
What's going to happen if we divide it by s? We now have this is over s, and this is just a plain old s here. We're going to square it, and then we have these fractions, and we're going to get rid of the fractions by multiplying both sides by s squared. And so that just, so we could take the s over there, and then later on we're going to do a step where we're just going to bring it back. But nothing wrong with taking the s over there and then doing that. I was saving a slight step.
What are the equations on the right side of the board at all? Like how do they differ from the equations on the left side? Is it just another way of doing it?
The equations on the left side going over here.
Yeah.
This is just step by step, the progression.
Oh.
Yeah, this is all the same
Excellent.
problem. We're still, this is the hardest of the projectile motion problems.
Yeah.
We square both sides. Now I have two terms here that I'm gonna square. How do you square it? It's binomial. How do you square a binomial?
Complete square, so like you have to do like that one multiplied by itself. It has to be like a, I don't know how to describe it, but you can't just multiply it by square.
So if I do a plus b squared
It's a squared plus ab plus b squared.
plus,
It's just FOIL.
yeah, it is just FOIL.
Yeah.
So you end up with the a squared plus 2ab plus b squared. Because when you do outer and inner, they're both ab. I didn't hear the two.
Yeah, I forgot to see the two.
Okay. And the bridge collapsed. That's a little twist. After I found out that my mom had ovarian cancer, that particular semester, every single example I did for about 2 months, death and destruction. It was just very bizarre. Anyway. So now we square both sides, so what is this squared?
That one number is 0.0375196.
Minus,
125.
what again? I thought somebody said something.
125 square. I mean, 125 less. No.
It's gonna be 2 times that times that. Ah, you were ahead of the, yep. Let's go ahead and put that in, plus 0.25 s to the 4th power is equal to s squared times 1 minus s squared.
Negative 1.937.
Negative
Wait,
1 point,
No, 0.1937.
0.1397.
93.
That last one's a 3. David, one more time, with feeling.
0.1937. Is that
Okay.
correct?
How could you?
That's not-
S
Wait, how do you
squared.
get
They said, so it's A times B. So
S.
it's,
Isn't
It's
it?
2 times A times B.
yeah, so I'm looking at this.
Yeah, I got the same thing.
Oh, yeah, because 2 times 0.5 is 1 times that, yeah, that makes sense. Oh, and that should be an S squared, not C squared. Can't believe not every student got this when I put it on the test.
You can.
All right, at this point, just do a quick check, did I lose something here?
Oh, that's just S, not S squared, right? No, it is S squared. I'm great.
Look, because we're just cutting it in half and multiplying it again.
Yeah.
So that is S squared. All right, let's double check, make sure I didn't lose something somewhere. All right, so I've got that. Rationalize the denominator. So 1 minus S squared, then combine them because they have common denominator. Then multiply, got rid of a fraction. Then 1 minus S squared, 30.6, and then add that over. And then distribute it, negative 50 plus 50S squared, plus that, and that stays the same. And combine those two numbers, plus 50S squared is that, got rid of the 100, so divided that out. And left with S times that, so I got S squared minus that. Okay, I don't see a mistake. Still feel like something's off, but. All right, now we distribute this, it will have a 4th order function. If I divided by S there, I'd have that over S, and that times S. S squared, I'd have 1 over S squared, I'd have an S squared, and then I'd have a constant term. I would not have. Oh, okay, sorry, my bad, we're good. So over on the right hand side here, I have S squared minus S to the 4th. I was thinking we were gonna end up in the S cubed term and there shouldn't be, so. Then I actually stopped and thought. So now I have a 4th order polynomial, a quartic. Let's start with a fresh screen here. Assume somebody have these numbers written down so that I don't have to remember. All right, so we have 0.03.
751969 minus 0.1937 S squared plus 0.25 S to the 4th equals S squared minus S.
All right, how do you solve a quartic?
I would combine like terms first and set it equal to 0, and then make a substitution where like x equals to s to the second power, and then we'll just quadratic formula our way out.
If we had had an S cubed term like I panicked on, then you're gonna look that up. There's just like there's the quadratic formula if you have a 2nd order polynomial. There's a formula if you have a 3rd order polynomial. There's a formula if you have a 4th order polynomial. I think that's as far as they've gotten. I have seen it. It is long and complicated. However, we don't have to deal with that we will make the substitution that Robin suggested. First, let's get everything on the one side. So I have 1.25 s to the fourth. Then subtract that, minus 1.1937 s squared, plus 0.0375169 equals 0. I conveniently do not have the odd polynomials, or the odd exponents. So I can make a substitution, and why not just do, I'm gonna let x equal s squared. So I end up with 1.25x squared minus 1.1937x plus 0.0375169 equals 0. And now this should be more familiar to you. It is a classic quadratic equation. We use the quadratic formula. We'll end up with two answers. That won't be the end of it, but that intermediate step. So we use quadratic formula. So x is equal to 1.1937 plus or minus the square root of 1.1937 squared. And for those who really want to, you can square the negative too, but b squared minus 4 times 1.25 times 0.0375169 divided by 2 times 1.25. And there'll be two solutions that someone is going to share with us.
They're both positive answers?
Pardon?
They're both positive answers?
I don't know.
Because I got, for my first answer, 0.03254. And then the second solution is 0.922419.
Anyone else get those? Or is it time to stand up and go, Robin, come on, how could you?
I would never.
I'm not sure if anyone else caught this, but I have a negative under the radical.
Oh. That is, so that's going to be 6. That's 0.03, which would put it at. Let's see, 6 times 0.3, that'd be 1. That should be 0.18 there. That's going to be bigger than 1. Yeah, I'm not quite sure. I don't think you should have gotten a negative under the radical. If you had a negative under, if the thing had not made a mistake, a negative under the radical there would tell us that the problem's impossible.
I did not get two positive answers.
What did you get?
I got, for the first one, I got, the positive is 1.269728496. And then the negative is 0.01748496. 8496, sorry. 8496.
So 1784?
174-48496. Sorry.
All right, so we have a different set of answers. Anyone get those? It is possible to have two positive answers here. It's also possible to have a positive and a negative. And two negatives. It's okay to have at least one negative, two negatives. Don't think two negatives would work. Did you not? For you, for all those international fans out there, place your bets down.
My first answer is wrong, because I left a one out of the 1.19.
So, that, not that.
Let me-
Yeah, I
let me
also
redo
got
that
the
one.
first set of answers.
You got this?
I also got the first set.
You also got that? All right, fill in the groundswell here. When you did this, the negative sign should have gone away here.
Yes, it did,
Okay,
but whatever was for that was bigger than the first number, which is why.
and this is 0.03. Did you do 0.3?
Yeah,
Ah, okay. All right, so we seem to have a groundswell for these two right here. Let's just assume that those are correct. If they are not, then make sure you let the person know. Well, I guess let the three people who got the same answer know in the most physics way possible. Really? Oh, Alan, you're not getting that?
It's a completely different thing, so quite wrong, probably. Nope.
I would expect the magnitude of them both to be less than 1.
Okay, yep, see?
Because remember, x stands for sine squared. Sine is not bigger than 1. So sine squared is not bigger than 1. So these are our values of x. So what I'm saying is that we have sine of theta is equal to 0.03